Hi, welcome to the lecture for Chapter 7. A lot of information this time, but last chapter, we talked about data and different data, how it was acquired. Now talk about how do I use that data? How does business systems, how do they use it? So what is knowledge management? Knowledge management just basically is a range of practices to how do I foster learning, speed working together, innovating. So just different ways to how do I use the data and share it within an organization. Now there's several different ways of what kind of knowledge can I have. There's explicit knowledge, I can measure it and document it, and there is tactic knowledge, which is hard to measure, but it's not objective or formalized, but it's definitely information that's hard to manage. Now, many organizations attempt to convert this tactic knowledge to explicit knowledge so that they can share information, stuff that's hard to quantify. I got to find a way to share it with people. Now, there's a couple of different methods that companies have used to try to share this information. One is shadowing, and pretty much has a junior person following a senior person, watching everything they do, and through osmosis and conversation and stuff, they'd be able to learn the information. Or in some cases, you have a junior and a senior person jointly trying to solve the problem, working together, and that way passing on information or knowledge to a new person. Now, the question is why? What do I want to do with it? I want to be able to foster innovation. I want to, encourage information exchange amongst businesses, people, employees, suppliers, and then I want to leverage that expertise to help the whole corporation, organization. And I definitely want to make sure that I don't have a senior person in such a way that they've got all the knowledge but have no way of sharing it before they retire. So you got to find a way to manage that loss information as people walk out the door, whether it's retirement or loss or layoff or injury. You got to find a way to minimize that impact of losing high-paid resources. Now, some of the best practices for selling and implementing projects, well, I got to make sure that this knowledge management system is connected to the organizational goals and objectives. If it's not connected to the goals and objectives, nothing's ever going to get done. So you got to make sure the company is key on that. Now, granted, it's easier to start out small and work yourself back up. And two, you want to make sure you identify what is the most important information you want to capture. You don't want to just capture everything and then say most of it's unusable. You want to make sure you get the right stuff. And then you got to get, of course, the employees' buy-in. So you got to make sure that that companies value the knowledge and value the ability to capture that knowledge so it can be used. Now, some of the technologies that support this, you got communities of practice, you've got organization network analysis, web technologies, you've got some business management, so artificial intelligence networks, enterprise search tools. There's plenty of different technologies out there to help support this knowledge management. Now, community practices, basically groups of people that have common interest. You can consider them kind of a Facebook page, but it's basically, in this case, you're looking more of a business-related information. So they share information, they create it, they store it, they share it. But like I said, kind of like what you do on Facebook. There's a general services administration, that was set up by the government to kind of help, try to innovate in different areas and communities. You may hear a thing called organization network analysis. It's just a way of documenting the flow of information between groups and people, because you got to make sure how the information is flowing to make sure what's important. Now, of course, when you look at this organization network, each node represents a knowledge source. you may have heard one of the most significant data is metadata. It's data that describes other data. Depends on what you're looking at. If you're looking at medical studies, metadata may be not the way to go, or at least you got to be careful about where that data is coming from, because now you can be very selective. But it's basically as I captured information, I want to make sure I record only and use only what's important. Now, this organization network analysis has several, applications, from mapping knowledge flows to identifying knowledge gaps, maybe establishing collaborative networks. The internet, the Web 2.0, it's information sharing. Web 1.0 is basically this one-way direction. Companies giving you information. Well, now you can actually share information with companies. Whether blogs, forums, podcasts, wikis, tons of different ideas out there. Now, business rules management systems, they're just software used to define information that helps me to manage my business. Whether it's sending out business policies or decision flows, it can vary. But components of this is there's usually a rule engine, a database that holds all the knowledge, all the rules. Rules are just basically, if I got some information, what am I going to do with it? If I break my leg, call 911, go to the hospital. So it's just, what am I going to do under certain circumstances? So you got to have this repository storing all the rules, and then you got to have some software that's kind of managing different versions. And as the rules are modified, I got to make an update them. As I get more information, as I learn more things, I've got to change it. So, there are different enterprise software out there, but it's more like this: how do I search software that's within an organization? Because sometimes you work for a large enough company, you don't know what's out there and what to get access to. But here's some copy. Most of us are all familiar with Google and its search engine. I mean, that's definitely probably what most of us use for 90% of what we do these days. But this search software, as we're all used to using, it allows me to search, a website visitor. So what do they look at? What are they looking at? How long do they stay? So you want to analyze that software. Now, electronic discovery is an application. It's a process in which electronic data is looked at with the intent of finding, evidence of civil, in a civil or a criminal legal case. So it's kind of like you've already heard a court case. I'm going to do a discovery. I'm going to try to discover information. Well, now it's electronic discovery. Predictive coding, it's a recent development, but it basically involves algorithms to try to review documentation, for relevance as far as whether legal documents are used for in a lawsuit. Artificial intelligence, a huge part of business. I mean, we've all heard Watson and maybe heard that Watson playing Jeopardy, or you've seen the television commercial that's helping doctors. But artificial intelligence is a big booming business, and you're hearing just about every major computer company talking about it. Basically, it includes people, process, procedure, hardware, all for the purposes of trying to get the computer to think closer to what we do. So it wants to learn, reason, maybe self-correct itself. It's used in a lot of different fields. It's an interdisciplinary field, so it crosses several different boundaries. Now, what is intelligence? Now, basically, there's a Turing test, which basically says, hey, can a computer successfully impersonate a human? British mathematician back in, I think, World War II came up with a test, but no computer has actually done it yet to pass that test. But intelligent behavior includes learning from experiences, apply the knowledge, handle complex situations, solve problems. So there's a lot of different things to what intelligence has. Now the question then becomes, okay, how do I now have a brain-computer interface? Now brain-computer interface is, how do I now connect the brain to a human? So it's definitely, how do I control with people without arms, without legs? Expert systems are fast approaching, because I'm running short of some experts, hardware and software that stores knowledge and make references, includes databases that allows me to ask rules, questions, that allows me to be able to answer questions via the computer versus anything else. Ideas, here, components of an expert system, you got a knowledge base, where's all the rules? An inference engine that says, okay, I've got to make based on that data, I got to kind of make a decision. Maybe an explanation facility that says, hey, I got to explain what is going on. How did I get that information? The knowledge-based acquisition says, hey, how am I gathering information? Of course, I've got to interface to the users. So we'll go through a few of these. Knowledge-based, it's basically in storing all the relative information. The rule is just basically a statement of the actions versus outcomes. So it's kind of an if-then. So if certain situations occur, then this probably happens, like a doctor diagnosing a case. An inference says you seek and build relationships. Explanation allows you to understand how did the expert arrive at the conditions. Knowledge acquisition. I just got to find a way to get capturing more and more information, and of course I got to make sure that users can use the system. Now, the types of people developing expert systems, one, you got a domain expert. He's the person or a group of people with the expertise and knowledge that you want to actually receive information from. The knowledge engineer, he's actually developing and building this system. And of course the knowledge user is the one that's going to, I don't have any expertise, I'm not a medical expert, but I got to be able to use the tool to come through. Now expert system shell, it's just software that allows the construction of the knowledge base, whether it's on a computer, personal computer or mainframe. Now, this whole branch of engineering called robotics, and basically says, hey, what am I doing? I'm taking machines and trying to get them to do human aspects. So they perform a lot of tasks that we don't usually want to perform. And I'm sure we're going to find ways that robotics are going to drive cars and everything in the future. Vision systems now, wait a minute, I've got eyes and see, they're very complicated. But vision systems are basically, I'm going to capture and store data. And applications, whether it's increasing accuracy or speed of inspecting of parts, to recognizing facial recognition. Natural language, how do I interpret, understand English? How do I do voice recognition? Learning system, how do I capture information? How do I learn and provide feedback? Neural networks, computer system recognize patterns. So there's a lot of information. Application, genetic algorithms, intelligent agents to perform specific tasks. We're all into multimedia and virtual reality. We understand what computers are trying to do. They're trying to simulate our reality via computers. Multimedia, text, audio, video, tons of it. We use it on a daily basis. Sometimes the files can get large and cumbersome, but we learn more by pictures. Virtual reality enables one or more users to play. So different devices, got head-mounted displays, virtual reality, touchscreen monitors. You've got forms of reality. I can get immersive. You can get applications, augmented reality submissions. Where are the applications? Medicine, education, business, assistive technologies. Game theory helps apply this to solve the problems. You got informatics that allows you to combine, pictures and stuff. Health information. So there's several different aspects of this. So it's a brief summary of knowledge management, artificial intelligence, multimedia, and specialized systems. Thank you.